of the data analysis using the cohort study. So usually in the cohort study, we need to measure the outcome frequency and also need to measure the association between the exposure risk factor and the disease outcome. So for the outcome frequency, we usually use incidence rate, cumulative incidence, incidence density, standardized mortality ratio to measure the outcome frequency. And for the association, we usually use relative risk, and which is the most important indicator to measure the association. And sometimes we could also use this called attributable risk, and attributable risk percent, population attributable risk, or the population attributable risk percent. And now let's look at the measures of the outcome frequency indicator. And the first measure is called incidence rate. The incidence rate is the number of new events in specified periods divided by the average number of persons exposed to risk during this period. And in the cohort study, this is one of the most important index using to measure the outcome frequency. And this can be used to describe how severity of this disease and how many new cases have happened in a population. The next one is called cumulative incidence. So this cumulative incidence is calculated by the number of new cases of a specified outcome during a given period of time divided by the total population at risk. So this cumulative incidence is the number or population of a group of people who experience the onset of health-related event during a specified time interval. And the difference between this cumulative incidence and the previous mentioned incidence rate is that the incidence rate, in the incidence rate, the number of new events is happened in a specified periods, while the cumulative incidence, the new cases can be identified during a given period of time. The next one is called incidence density, and let's look at the formula first. So this incidence density is calculated by the number of new cases of a specified outcome during a given period of time divided by the total person time of observation. So as you might already notice that the most significant difference is the this total person time of observation. So how can we define or how can we calculate this person time? So for example, one person can be followed up for 1 year, so the person time is 1 person year. A person can be followed up for 10 years, so the person time is 10 person year. If 2 persons are followed up for a year, so it's 2 person year. So if 2 persons follow up for 10 years, so it's 20 person year. So the reason we are going to use this person year because not everyone they will follow up full time during the cohort study. They might drop out during the middle of the study. So we need to use all available information during this entire period of follow-up in order to give more accurate measures of the outcome frequency. The next one is called Sterilized Mortality Ratio, SMR. SMR is calculated by the number of deaths that observed in the study populations divided by the number of deaths that expected based on mortality rate of a general population. So this SMR is usually used when there are only few cases of deaths observed in the study population. This can be used to indicate whether study population had unusual mortality rate, usually, for example, either higher or lower mortality rate compared to general population. For example, is if the SMR equal to 2, so which means the study population have 2 times higher of mortality rate compared to general populations. So next one, let's look at the measures of the association between exposure and the disease outcome. And here is a table that presents the data from a cohort study by this 2x2 table. So we know that the exposure, the group can be divided by exposure status by yes or no. So which means exposure to some risk factor or not exposure to risk factor. And their disease status, which means they either get the disease or they not get disease. And the numbers can be observed during the follow-up time. And let's say we assign this A, B, C, D into these 2x2 tables, and we can easily calculate that in the exposure group, the disease incidence can be calculated as A divided by N1. So N1 is equal to A plus B. For the group that is not exposed to risk factor, the disease incidence can be C divided by N0, N0 equal to C plus D. So the baseline, so the basic principles of cohort study is try to compare the difference of the disease incidence in these 2 exposure groups. And during the data analysis, we usually use some indicators to calculate the association. For example, we can use this relative risk. So relative risk is one of the most important or most frequently used indicator in the cohort study. It can be defined as the ratio of the incidence of disease in the exposed group divided by the corresponding incidence of disease in an unexposed group. And here is the formula. And usually we can get any numbers of the relative risk as the result. If relative risk equals to 2, which means that the incidence rate are identical between the exposed group and unexposed group. If a relative risk is larger than 1, it usually indicates that a positive association or an increased risk among those exposed group is found. If relative risk is less than 1, it usually means that there is an inverse association between the exposed and the disease outcome, which means the more exposed, the less disease outcome. And next one is called attributable risk. So let's look at the definition first. So this attributable risk is the proportion of the rate or risk of a disease in exposed individuals that can be explained or attributed to the exposure. So this attributable risk can be calculated by the difference between the incidence rate in the exposed group and the unexposed group. And here is no formula we usually use to calculate this risk ratio. So here is one thing we need to clarify between the difference between the attributable risk and the relative risk. Usually, the relative risk is more like a measure of a strength of this association between exposure and the disease. So we're more likely to use this relative risk to measure the etiology of a disease. But in comparison, this attributable risk, usually they can provide more information about how big impact of this exposed and the disease on the disease in a public health perspective. So it's more like if how much of this exposure risk can have impact on the disease outcome. For example, how much of this smoking can increase the risk of the cardiovascular disease. And sometimes we also use this called attributable risk percent, AR percent. So this AR percent is to estimate the proportion of the disease among the exposed that is attributable to the exposure, or the proportion of the disease in that group that might be prevented by eliminating the exposure. So let's look at the formula. So this AR percent equal to I1 minus I0 divided by I1. As we have mentioned, I1 indicated the incidence rate in the exposure group, while the I0 indicated to the incidence rate in the unexposed group. So this AR percent very clearly is trying to understand how much percent of the disease can be attributed by the exposure in the exposed group population. And very similar, we have this population attributable risk, and later on we will mention the population attributable risk percent. So this PAR, or this population attributable risk, can be used to estimate the incidence rate of the disease that is attributable to the exposures in that populations. So it can provide insight into which exposure have the most relevance to the health of a population. And let's look at their formula. So this PAR equal to IT minus I0. So this IT is the incidence rate of a disease in the total populations. And this I0 is the same. It's the incidence rate in the unexposed group. So this PAR can understand is that in the general population or in the total population, how many of the incidents can be attributed to the exposure. And the next one is called population attributable risk percent. And let's look at the formula directly. PAR percent equal to IT minus I0 divided by IT. So as we have mentioned, IT minus I0 is PAR, right? So this IT minus I0 means in the total population, the incidence that can be purely experienced by the exposure. And divided by IT means how much percent of this exposure relative incidence in the total populations. So this PAR percent can also give us an overview about how much series of these exposure can be or can have impacts on the general populations.